Okay, so we're going to practice calculating the residual from an equation. So this question says, Joe sells used cars. He recorded the age in years of each car on his lot, along with the number of kilometers it had been driven. After plotting his results, Joe noticed that the relationship between the two variables was fairly linear, so he used the data to calculate the following equation for predicting distance driven from the age of the car. What is the residual of a car that is 2 years old and has been driven 50,000 kilometers? Okay, so I have this car, it's 2 years old and it's been driven 50,000 kilometers. That's going to be 1 point in the graph. And then I have this line of best fit represented by this equation. So over here, my apologies for my handwriting, we have the equation. So I just copied down the equation from here. And then I also made a point, an ordered pair from this particular car. So this is a car that's 2 years old, so the X value is 2, and it's been driven 50,000 miles, so the Y value is 50,000. I'm just going to go ahead and label the 2 is the X, and the 50,000 is the Y value. So eventually we'll be plugging in this X and this Y for the equation. Okay, so off to the side here, I'm going to quickly write the equation for residual. So we calculate the residual from an equation using this formula. The formula is we're going to take the actual value and we're going to subtract the predicted value, which I'll explain what those things are in a second. So just to keep in mind, the residual is always going to be the actual value minus the predicted value. Okay. So, a few important things. The actual value is going to be the value that we get when we plug a number into our equation. Sorry, the predicted value is the number we're going to get when we plug a value into the equation. So for me, I'm just going to label the equation with predicted, just so I can keep straight in my mind that this is how I'm going to be calculating my predicted value is by using my equation. The actual value is going to be the actual real value of the car, which we already said, a car that's been owned for 2 years has been driven for about 50,000 kilometers. This is the actual, real car that we're looking at. The actual mileage of a car that's been owned for 2 years. Okay, so I'm going to calculate the predicted, and then I'm going to subtract the actual, and I'll show you what that looks like. So to calculate the predicted value using the equation, I'm going to ask myself, for a car that's 2 years old, what value would my equation predict? So in other words, when I plug in 2 for X, so I'm going to be plugging in 2 into this X value. I'm going to plug and chug that in. Let's make sure it's clear. I'm plugging in the 2 into the X. What is the Y value I get out? So when I plug in 2, what's the predicted Y value? Or what's the Y value that my equation predicts? So what I'm basically going to do is I'm going to replace this X with a 2. And then I'm just going to plug this whole thing into a calculator. So let's do that. So I have, okay, accidentally went ahead without recording, but I will go back and explain what I just did. So in the calculator, I plugged in 11,000 plus 18,000. So just the equation, 11,000 plus 18,000. And then instead of the X, I replaced it with that 2. So I'm trying to predict the value, the mileage for a car that's 2 years old. So I'm plugging in 2 for X. So I just replaced the X with a 2. And it gave me a predicted Y value of 47,000. So I didn't want to rewrite the whole equation, but here I have, okay, if I plug in 2 for X, it's going to give me this predicted Y value of 47,000. Let's do some color coding. Okay, so my predicted Y value is 47,000. That's my predicted Y value. Now, my equation, when I plug in 2, it predicts that a car that's 2 years old is going to have a mileage of 47,000. There's a problem though, because I have this actual car, and this actual car is 2 years old and has been driven for 50,000 miles. So there's a difference, right? My equation tells me it should predict that for a car that's 2 years old, it should have about 47,000 miles. But my equation is not perfect, obviously, because I have an actual car that has a mileage of 50,000 miles, right? There's some difference here. These are pretty close numbers, 47,000 and 50,000, but there's a little bit of a difference. And that difference is what I'm going to call my residual. So to calculate the residual, I'm going to take the actual value of the car, which I will put in green. So the actual value, going back to my actual car here, is 50,000 miles. My equation predicted it would be 47 miles. So I'm going to take this actual value and subtract the predicted value to get the residual. So my actual value comes from the point, that's 50,000. My predicted value I just calculated using the equation. My predicted value is 47,000. So what I did is I took 50,000, I subtracted 47,000 to find the difference between these two numbers, and the difference is 3,000. So my residual, my final answer is 3,000. Sorry, it's kind of hard to see that my final answer now that I boxed everything. But my final answer, this is my residual, is 3,000. So to break it down into some steps, my first step is I wrote out my equation, and I recommend writing out these steps on a piece of paper, like writing what I have here on a piece of paper. So I wrote out my equation, I wrote out the point that I was given, I plugged the X value from my point into my equation to get the predicted value, and then I subtracted the actual value from the point from the predicted value of the equation. So actual value minus predicted value, 50,000 minus 47,000 gave me a residual of 3,000.